Welcome to Inside Blockchain Podcast. My name is Tony Obiajuru, but you can call me Tony Talks. What I intend to achieve with this podcast is to help you make sense of the blockchain industry and how this amazing technology is redefining work, setting new paradigm shifts in businesses, and helping to reshape societal interaction. I bring you Inside Blockchain Podcast, the most intellectual source of discuss with industry leaders and enthusiasts. Now here's just a brief disclaimer. All opinions shared by our guests on this podcast are exclusively their own opinions. They do not suggest investment recommendations of their companies, neither should you take this information as an investment advice, as you are solely responsible for your own investments. On today's episode, we will be discussing one of the consensus models, which is the proof of stake. And my guest today joining me all the way from Kenya is Felix Macharia. He is the COO of EOS Nairobi and also a co-trustee at the Africa Digital Assets Foundation. The topic we're going to be talking about is everything and anything that has to do with the POS ecosystem. Now, here is just a brief on Felix. He has 3 years of experience in blockchain supervising, blockchain education, research and development for EOS Nairobi. He is also an infrastructure provider for the EOS blockchain protocol and EOS SisterChains. Felix also works for the Africa Digital Assets Foundation, where he is charged with strategy and community development for the Consortium of blockchain companies looking to build businesses on this new technology. Hello, Felix. Thank you for joining me on the show today. How are you?
Hi, Tony. Thank you for inviting me.
Yeah, you're welcome. You're welcome. Okay, so the topic is the POS ecosystem, and you were actually chosen because of your years of experience, all right, in this particular field. So tell us about these consensus models. What is proof of stake?
Okay. To understand proof of stake, one must backtrack a bit to 2008 and understand the consensus algorithm that underpins Bitcoin's technology, and that is proof of work. So you might have to bear with me, Tony, maybe just for the purpose of our viewers. A blockchain, what is a blockchain? So basically a blockchain is a bunch of digital files with transactions called blocks, which are cryptographically hashed and connected together. And they form one continuous immutable record, hence the chain in blockchain.
Okay.
Now, this particular record or ledger is not stored on a single server or database or computer as it is with traditional tech. It is actually distributed around a group of computers called nodes.
Okay.
And these nodes are connected in a network like the Bitcoin network. Now, obviously, for us to maintain a single record or ledger, we must all agree on what the contents of the record or ledger are. And not only that, we must also agree who gets to add the next transaction to the file or block. And that's where really the issue of consensus comes in.
Okay.
So So you have these consensus algorithms, which are pieces of computer code that are written and they're implemented in blockchain protocols to enable the various computers, the various nodes on the network to be able to reach consensus with each other. Okay. On what? On mainly two things: on who should add the next transaction to the block and what the actual contents of this ledger should be.
Okay, so that is what the consensus models are designed for.
That's what consensus algorithms are, yes.
Okay. So go ahead, please.
Yeah, so this was the genius of Satoshi Nakamoto, the anonymous creator of Bitcoin. He basically found a way to make this process of reaching consensus possible without having to trust a centralized entity, to help us, reach consensus with each other. And he called that particular consensus algorithm proof of work.
Okay.
So the way proof of work functions is almost like a lottery. And I think you cannot understand proof of stake until you have understood
Proof of
sort
work.
of like proof of work.
Okay. So
Yes.
tell us about
so
proof of
basically, yes. So basically what you have with proof of work is you have these nodes around the world that are working hard to solve a difficult mathematical problem. The first node or the first computer to solve this mathematical problem is awarded bitcoins by the software, and basically this is what is called mining, because these bitcoins are rare and they can only be produced by this process.
Okay.
Now, that same node also gets to add transactions on the block and transmits this information to other nodes on the network, so that we have now a distributed account or a distributed record of transactions.
All right.
Now, solving this difficult mathematical problem is very dependent on computer resources. So we are talking CPU, we are talking RAM, we're talking bandwidth, and we're even talking electricity. So it basically means the more powerful and the more energy efficient your node is, the more mathematical problems you can be able to solve, and therefore the more bitcoins you can earn.
You can mine.
Yes.
Okay.
Yes.
Okay.
So this is why it's easy, for example, to be able to run mining farms in places like China, because there is good electricity. The microchip industry, exactly. The microchip industry is quite developed, and so on. So anyway, this particular system developed by Satoshi proved to work very well, because it meant for someone to change the ledger, they have to first decrypt all the transactions on the chain, because each transaction that is added onto a block is actually encrypted. It passes through a hashing algorithm and is encrypted. These are cryptographic methods. Then, apart from decrypting the transactions on the chain, one has to add their own transactions if they want to change, and they have to encrypt those transactions. And simultaneously, they must also be able to at least control 51% of the networking resources. So basically, these two things make it very difficult, very resource intensive for any computer around the world to do. Actually, with the current computers we have and with the kind of energy available, it is sort of like impossible to do these two things at the same time. So it makes Bitcoin's technology very robust, very unhackable, very secure. And for that reason, it made a lot of sense for Bitcoin to be a base for decentralized internet money. So the Bitcoins that everyone talks about. Now, proof of work faced sort of like a challenge, and that was mainly the electricity demand. So we would need all of the Earth's energy to run transactions as more and more people, entered the network. In fact, I think the Bitcoin network at some point was using as much energy as 3 nuclear reactors at that time. The other challenge was, because we must compete to solve this particular hard mathematical problem, then the process of reaching consensus is kind of slow. And for that reason, Bitcoin proved to have very slow transactions, about 4 transactions per second. Now, the Bitcoin community has since worked on some of these scaling problems, and they have an initiative called Lightning Network, which has helped them sort of like scale up the number of transactions you can have on Bitcoin, but not to the extent required for real world applications. For example, if you were to try and build a Facebook on Bitcoin, people will have to wait at least 30 minutes for a like or a comment to be passed across the network. So it's quite slow for real world applications. So right now, because of its characteristics, Bitcoin remains very much a store of value. It's more of digital gold than anything else. So this is where now proof of stake entered to solve some of these issues. So yes.
Before we talk about proof of stake, I understand that these consensus models are actually the technical aspect, or I can call them analysis of a blockchain project. But my question is, does proof of work have anything to do with validating a transaction on a block?
Yes, very much. For you to be able to be selected to add a transaction to the block and transmit that transaction across to other nodes on the network, then you need to compete. You need to participate in this process of trying to solve the hard mathematical problem. The algorithm, the computer code chooses the particular node that solves the problem. So we use consensus algorithms to agree or to choose randomly the particular node that solves the mathematical problem first. So it's very much an important part of validation.
Okay. Let's talk about proof of stake right now. What role does it play?
Okay. So back in 2012, I believe, that there were two gentlemen who wrote a research paper. One gentleman was called Sunny King and Scott Nadal. And basically, they were trying to propose a new method of reaching consensus while still maintaining the advantages of traditional blockchain technology. That is the security, the immutability, and so on. So proof of stake is a system whereby your stake in the system in terms of the number of tokens you own puts you at a better position to run transactions on behalf of the network. So simply put, the more tokens I own in a proof of stake network, the greater my probability of being chosen as the next node to run transactions. So with this particular system, there is no racing, there is no competition that is wasteful. Basically, stake in these systems determines status. Now, if you think about it, it makes a lot of sense. If I own more stake in an ecosystem, I should make more decisions. Because if the ecosystem fails and I had bought all these tokens, I have much more to lose than somebody who had bought less tokens than I had.
Okay, so let's bring this down to the normal corporation or a company, the way a company operates. So we say proof of stake is just like shareholding, right? Like purchasing a huge amount of shares, which allows you to participate in the decision making of that particular organization. So is that how proof of stake works? Like the more stakes you have, the more power, right, you have to make certain decisions within the ecosystem.
Yes, pretty much. So in the case of something like Facebook, the fact that Mark Zuckerberg as a person owns a very large stake, a very large percentage of shares, and even in fact voting rights, means that he has a very huge say in the direction of the company. So with proof of stake, the validation rights increase as your stake in the ecosystem increases. So yes. So it also means that as a higher staker, I have more interest to preserve the network's value. And if the tokens are distributed well, I will not have too much control of the ecosystem. So one of the worries that people have with proof of stake algorithms is it's sort of like it's a rich man's game, like if I own more stake in the ecosystem, it's sort of like I'm more important than everyone else. But what matters is the models of token distribution. So there are various models of token distribution that are currently available around the world. So one good example, of course, is the ICO model, which has with time has sort of like gotten old and quite regulated.
Yeah, that's the initial coin offering.
Yes, that's the initial coin offering.
Okay.
Yes. So there are other methods that people are using to sort of like distribute these tokens. One of the methods is called an airdrop, where basically you just give out the tokens for free to accounts on a network. In the case of EOS, whenever anyone launches a new chain on EOS, they can always take a snapshot of the initial EOS mainnet. We'll probably discuss this later, and they can give everyone on mainnet a couple of tokens. So you distribute the tokens to thousands of people or even millions of people around the world at the same time. So if I was a user and if I want to sort of like have more say in the network, I need to buy more tokens to be put in a position of higher probability to produce blocks. So the person who has, let's say, 1 million tokens has a greater probability of producing transactions on behalf of the network in comparison to somebody who has, let's say, 200 tokens.
Okay, so
it also means that,
go ahead. Go ahead, please. I was going to drop a question, but I'll bring in the question very soon.
Okay, thank you. It also means because it is easier for us to choose the next miner, sort of like we have these huge stakers within the ecosystem. So we know that the transactions, whoever is running the transactions is really these huge stakers within the ecosystem. And all we have to do is randomly assign each node on the network, sort of like time to produce blocks. So it makes it easier to produce blocks. It makes proof of stake protocols faster. And for that reason, with proof of stake protocols, one can run more transactions.
Than proof of work, right?
To look, yes, than proof of work by far.
Okay. Then this serves like a more preferable alternative to proof of work. And since you've already started highlighting the what do I call it now, the benefit of the POS blockchain, what is now the cost of running it? Is the cost of running it higher or lower than the cost of running a proof of work ecosystem?
So the cost is definitely lower than the proof of work ecosystem, basically because it uses less computing resources for everyone on the network. Because we are not competing. Yes, because we are not competing, and we know who should be next in producing sort of like these transactions and adding these transactions to the blocks and adding the blocks to the chain. We don't all have to be using CPU, RAM, net, and bandwidth at the same time. We only use it when it is transmitted to us, and we only use it when we are the ones who are producing blocks. So it's a much simpler, much cheaper, less cost intensive process of reaching consensus. And if you actually think about it, that's all proof of work consensus algorithm was meant to do. It was meant to reach consensus. So the characteristics of the underlying blockchain technology are not really changed. Proof of stake protocols are secure, and they have a high sense of security. They have immutability. They have transparency. That you will basically find in Bitcoin, but only that this time the method of reaching consensus
is different.
Is quite different.
Okay, so now what are the examples of protocols that are using proof of stake? You might want to give that in line with a proof of work. So let's talk about these the examples of these protocols. What are they?
Okay, so people went ahead and took this paper written by Scott Nadal and SisterChain back in 2012 on proof of stake, and went on to improve on proof of stake as sort of like a consensus algorithm. And they came up with various variants of proof of stake, and the various variants of proof of stake that are out there determine the various kind of protocols that you find out there. So there are various chains that use proof of stake. So there is EOS, there is Tron, there is Neo, there is Komodo, there are quite a number. There are about 21 by my counting, and basically each of them have a variant of delegated of proof of stake. So for example, in the case of EOS was proposed by a gentleman called Dan Larimer back in 2014. Dan Larimer is famous in the blockchain ecosystem because he came up with two previous protocols, I think Steemit and BitShares. So he proposed taking this proof of stake model, and instead of just the guys who are the highest stakers in the ecosystem having to be the ones producing blocks, he said we can use our stake. The stakers in the ecosystem can use their stake, can use their tokens to vote for a delegate. And this delegate can then produce blocks on behalf of the network. So he called it delegated proof of stake. So exactly. So the way delegated proof of stake works, for maybe people who are not very
go ahead.
They're not very involved in the space. it's almost like a democracy. So you in a democratic country, you have all these citizens who have citizenship rights, and one of the citizenship rights is the right to vote. So you can vote for a leader, and that leader, once he receives the largest number of votes, is the one who
is
actually
elected.
gets to lead. Exactly. So it's the same with proof of stake algorithms, only that with this delegated proof of stake, for example, what is found in EOS, the voting is actually throughout. So if I wanted to vote for a leader or for a particular delegate now, I will vote for them. And if I wanted to withdraw my vote, I can withdraw my vote. So you'll always find that with delegated proof of stake, there is sort of like movements on the table. There are people who are coming in, there are people who are moving out. But by the end of the day, the people who have the highest number of votes are the ones who are producing blocks on behalf of the network. The way EOS works is there is one.
Quickly. So who are those that are validated to vote? Are they those who have the highest number of tokens, or anyone with any amount of balance in their wallet?
So anyone with
regardless,
tokens, can vote using their tokens.
Okay.
Yes, regardless of like what amount of tokens you have. It's only that the tokens you have give you a certain power. So, for example, if I had 1 million tokens, it gives me more voting weight than if I had
somebody that has
less.
10. Okay.
Yes,
I see.
But it's a more democratic model, because what happens is the people who are chosen as delegates are actually people from the community. So depending on the kind of protocol, you'll have different demands on these delegates. In the case of EOS, for example, you are required to have a website, you are required to say who the team members are, you are required to verify the node location, you are required to say what you will do for the community. So why should the community really vote for you? What is the value add that you are bringing towards the community? So it's a very it's an intensive process that involves a lot of people, and for that reason makes these particular communities quite robust. In the case of EOS, there are 121 of these delegates. They are called block producers. Block producers because they are producing blocks. That's essentially what they're doing. They're producing the blocks we talked about earlier on behalf of the network. There are 21 main block producers on EOS, and then we have about 100 standbys. So the way it works is they are known as top 21 because they have the highest number of votes. These 21 delegates are the ones who randomly are chosen by the consensus algorithm from time to time to produce blocks on behalf of the network. And in case any of them is hit, sort of like any of them is pushed out, they can be replaced by a standby block producer. So the person in number 22 will immediately replace the person in number 21. Now, yes. So delegated proof of stake has proven to work very well, and for that reason there are many other chains that have come out with sort of like similar models. So like with Tron, we have, I think, a similar model where you have 21 super representatives. They're called super representatives, and then you have backup representatives. On something like Icon, which is launching sometime in August, they have 22 main public representatives, and then they have 78 sub PREPs or sub public representatives, and it goes on like that. There are other different forms of proof of stake. For example, what we have in Tendermint and what we have in Cosmos. So they work with something called asynchronous Byzantine fault tolerance, and they combine this with delegated proof of stake to sort of like make the decision on who should be the next person to produce blocks. Yes.
Okay, so now how big is this POS industry, and what are the interesting things that people are actually doing?
Very good question. So the top 10 proof of stake protocols right now are above $100 million market capitalization, the top 10.
Oh, wow.
And therefore, if you do the math, roughly that comes to about total market capitalization of $11 billion for the proof of stake protocols that are out there. So if you're to take the total number of tokens that are out there and multiply by the price, the current price of the token in the exchanges, in the markets, it will amount to about $11 billion for all of these protocols. Now, these protocols need to pay the people who are staking or the people who are producing blocks on behalf of the network. Because remember, in the case of Bitcoin, in the case of proof of work, when the miners are racing with each other to solve this difficult computer algorithm, they are normally rewarded Bitcoins at the end of that process. So if I'm the one who solves the problem first, I'm rewarded Bitcoins, and that's what we call Bitcoin mining.
Oh, okay.
But for proof of stake, what you have is you have the miners or the block producers or the the public representatives, all those validators. They are normally paid from a network fee, and the network fee can arise from two places. One, it can arise from when a user pays certain transaction fees on the network called gas fees. And I think people who are familiar with Ethereum know that on Ethereum, for example, you need to pay some gas to carry out some transactions.
Yes.
Of course, yes. Of course, there are a lot of dissenting voices for this particular model because it makes running applications on a chain quite expensive. And so the other method that people have found is using inflation. So the way inflation works is we have this total number of tokens, maybe it can be 1 billion tokens. We can have an inflation per year of about 1% to 5% of tokens. So the computer algorithm produces about 1% more tokens each year. And for that reason, these tokens can be used to pay block producers on the network, can be used to pay stakers on the network, can be used to pay validators for the network. Okay. The estimates currently by the Staking Alliance is that this particular staking economy, these stakers, these validators, these block producers, these public representatives around the world are being paid about $383 million every year. So we're talking about an economy of about $383 million. And remember that blockchain has not reached a point of mass adoption.
Wow, this is a big industry.
It is.
This is a big industry.
It is. So when, for example, what we let me just talk briefly about what we're doing in EOS Nairobi. EOS Nairobi, as you have rightly put, is an infrastructure provider for EOS and EOS SisterChain. So EOS SisterChains are just blockchains that look like EOS, blockchains that use the underlying EOS IO code. So our mission basically is to enhance blockchain adoption in Africa, and our vision since 2017, when we formed this particular community, has been to be a center for blockchain education, research, and development on the African continent. And for that reason, we believe that there is a lot of opportunity for African entrepreneurs, especially African entrepreneurs in the blockchain space, who can be part of this staking economy. It is not that difficult to actually become a validator or to become a block producer on these particular networks. What you need to bridge is you need to bridge a small knowledge gap as regards running a node, because obviously you need to know how to run a node, you need to know how to configure servers so that they're able to connect with other servers on the network. That's perhaps the only thing that stands in the way. But this is a very good opportunity for African blockchain entrepreneurs, because these networks are basically permissionless. There is no person stopping you from joining the network. And there is no person saying you're from Africa and we have these very strict guidelines and you cannot be able to join. You can join even from Africa, and you can participate in validating transactions on behalf of networks. And unlike proof of work, you don't really need those heavy computers, the ASIC and the GPUs and all those things that you hear Bitcoin miners talk about. You actually just need a server that meets basic minimum requirements. Depends on the particular blockchain protocol. And we are very interested in training people on the continent on how to stake on these particular networks, on how to run transactions on these particular networks. Of course, there are other trainings that we do. Maybe we'll talk about it later, like DApp when it comes to decentralized application development.
Yeah.
Yes. But this can be a very important source of income for African entrepreneurs and even African economies.
Okay, so now from my understanding of the comparisons between the proof of work and the proof of stake, so we can say the proof of work is incredibly secure, all right? Why the POS is actually new, all right? Proof of work is cost effective, but POS is less cost effective.
Yes.
Okay, so which out of the two? All right. Which one do you see taking the lead in the future when it comes to the consensus protocol? Which do you think will dominate the market?
Okay. So when I think about the various consensus algorithms, and when I think about which one will be more practical for the future of blockchain, I will have to say proof of stake, and I'll have to say proof of stake with various evidences. The first evidence is when you look at the number of transactions that can be run on a proof of stake protocol. It's pretty high. So if you're looking at blocktivity.info, which is a website that offers information on these transactions, the transactions being run by the various blockchains. If you look at blocktivity.info today, you will see that the top 8 or 9 blockchains there are proof of stake blockchains. So you're talking of EOS, you're talking of Tron, you're talking of all those blockchains, and basically they can be able to run a very large number of transactions. And because of that, then these particular protocols have been able to attract a lot of application developers. So again, if you're looking at the largest number of decentralized applications developed on blockchains, they are developed on proof of stake blockchains. I believe the two leading blockchain protocols right now in terms of the number of dApps are EOS and Tron, which are proof of stake blockchains, because it's not so much of a cost to the people who are validating on behalf of the network. And as an application developer, I do not have to think about the underlying technology or the politics of stakers. All I have to do is just plug and play. So today, if you're a developer who wants to build a blockchain application, also known as a decentralized application, there are many proof of stake protocols you can connect your app to. And as long as you know how to code in the usual languages, JavaScript, C++, depends on which chain you're also talking about. As long as you can be able to code, and as long as you own a few tokens on the network, then you can be able to build your decentralized application. And therefore, it's a very practical thing. So you will rarely find nowadays anybody who's building a new blockchain protocol talking about proof of work, because they know proof of work is quite intensive. The token that you are launching must be able to at least reach the price of Bitcoin for you to be able to incentivize people to maintain this very expensive hardware. And we know that obviously Bitcoin has been around for quite a while now. It has been around for 10 years. So your protocol, if you're to launch with a proof of work, would basically have a problem with the number of miners that you can have, because very few people will be willing to run servers at a loss. And so proof of work is a deterrent for people who are looking to launch protocols, but it is also costly to the people who are already running blocks on behalf of the network. So when you're looking at speed, when you're looking at ease of use, when you're looking at things like the ability to be able to plug and play, proof, and you're looking at the number of dApps that have been able to be developed on proof of stake algorithms over proof of stake protocols over the last 2 years, then it is very clear that proof of stake will lead. Yes, will lead. It will be the gateway for blockchain adoption, mass adoption around the world, I believe.
All right. Thank you so much, Felix. I actually look forward to discussing with the other guys that are part of the protocols the protocols you mentioned under the proof of stake, which have to do with the EOS ecosystem, the EOS chain, the Telos chain, and so on. And so in our next episode, all right, we are going to be having someone join us live on the show to tell us about the EOS, ecosystem, everything about the EOS, what makes it so unique, and a currency that people should look into investing. Thank you so much, Felix. Before I let you go, what do we expect to see, like, moving forward?
So there are several things you expect to see. Okay, so for this particular show, I think we will be hosting more proof of stake protocols. So it will be Cosmos, it will be Tendermint, it will be Komodo, it will be EOS, and it will be the various dApps that are building within those particular ecosystems. Because there are quite a variety. Yeah, there are quite a variety of decentralized applications that are building in those ecosystems. Everything from fintech to edutech to health to supply chain and so on. So it will be hosting some of those dApps as well for the various protocols. As regards the future of blockchain, I think proof of stake very much is proving very much to be sort of like the gateway for mass adoption. And for that reason, we are going to see an explosion of proof of stake algorithms, simply because it is a much easier process. And we also expect that as the blockchain space moves on, it's going to be a multi-chain and a multi-token universe, various ecosystems serving various purposes. It's going to be very interesting. In fact, one of the things that we are looking at the Africa Digital Asset Foundation is how we can be able to bring together these businesses. Initially, we had brought these blockchain businesses together to develop standards for the blockchain industry on the African continent, because these were virtually non-existent in 2017. There was no law, there was no regulation, there was no framework. But with time, I think ADAF may actually build a protocol of its own, and I think that protocol might actually end up being a proof of stake protocol. I think that we're going to have millions, thousands, if not millions of decentralized applications on the African continent, building on an African-centric protocol. So I guess we are going to see a lot of this around the world.
Yeah, coming soon. You heard it first from Felix. Thank you so much, Felix. All right, we've come to the end of this episode of Inside Blockchain Podcast. Don't forget to visit us at cryptotvplus.com for news updates, trends, sources, and links. You can also find us on social media at CryptoTV+. And if you come across our YouTube products, that is, I'm talking about our video, don't forget to hit the like as well as the subscribe button. So we'll come your way next time with the other protocols, which is the EOS ecosystem. It's a bye from now, coming from the studio. I am your host, Tony Obiajiru.